This is a lesson on the quadratic formula. This tutorial is being presented by Peter Smith. The goals of this lesson are to 1. Use the discriminant to find the number of solutions to a quadratic equation. 2. Determine the x-coordinate for the vertex of a quadratic function. 3. Determine the equation for the line of symmetry for a quadratic function. You may pause the video at any time and take notes. Let us look at the equation of a quadratic function written in standard form. The equation of a quadratic function, written in standard form is y equals ax squared plus bx plus c, where a, b, and c are constants. These are some numbers given in the equation, and a is not equal to 0. The x square in this equation is what makes it into this type of equation, which is called quadratic equation. So this is the standard form of a quadratic equation, where a is a number written in front of the x squared term, b is a number written in front of the x term, and c is the constant, or y-intercept. Now let us look at the quadratic formula. What is the quadratic formula? The quadratic formula is basically a formula used to solve a quadratic equation. The quadratic formula tells us that, if you have a quadratic equation of the form y equals ax squared plus bx plus c, then you can solve for x by using the formula x equals minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So this is a formula used to find the solutions of a quadratic equation. However, in this lesson I will not be showing you how to use the quadratic formula to solve a quadratic equation. What we will be doing in this lesson is to look at the different parts of the quadratic formula. There are two things we want to look at in this formula. One of these is called the discriminant. What is the discriminant? The discriminant is a part of the quadratic formula. It is basically the radicand. It is the expression under the radical. The discriminant is this expression, b squared minus 4ac. So this portion under the radical is called the discriminant. The discriminant is used to determine the number of solutions to a quadratic equation. It is used to determine whether the quadratic function will have one solution, two solutions, or no solution. It has some basic facts. And these are the facts. 1. If the discriminant is greater than 0, and it is a perfect square, this tells us that the quadratic equation has two real, rational solutions. So, if the answer you get from your discriminant are values like 4, 9, 16, 25, and 36, these numbers are perfect squares, and this will tell us that the quadratic equation has two real, rational answers. Let us look at an example. Given the quadratic function y equals 2x squared plus 5x minus 3, a equals 2, b equals 5, and c equals negative 3, the discriminant is given by the formula d equals b squared minus 4 times a times c. Substituting these values gives us d equals 5 squared minus 4 times 2 times negative 3. This equals 25 plus 24. D equals 49. 49 is a perfect square. Therefore, this quadratic function has two real, rational solutions. Let us examine this on a graph to see what we mean by two real solutions. This is how the function looks on a graph. Two real solutions means two values for x. These are the two values for x. Two real values tell us that the curve is at two places on the x-axis. Looking at the graph, we can see that there are two x-intercepts. These two values for x are 0.5 and negative 3. These two values for x are called the roots of the function. Let us now go to rule number 2. 2. If the discriminant is greater than 0, but it is not a perfect square, This tells us that the quadratic equation has two real solutions. But this time, these are two irrational solutions. So, in solving a quadratic equation of this type, you will end up with a number under the radical which will give an irrational solution. Let us look at an example. Given the quadratic function, y equals 2x squared minus 4x plus 1, a equals 2, b equals minus 4, and c equals 1. The discriminant is given by the formula d equals b squared minus 4 times a times c. Substituting these values gives us d equals negative 4 squared minus 4 times 2 times 1. This equals 16 minus 8. D equals 8. 8 is not a perfect square, therefore, this quadratic function has two real, irrational solutions. We can also examine this on a graph to see what we mean by two real solutions. This is how the function looks on a graph. Two real solutions means two values for x. These are the two values for x. Two real values tell us that the curve is at two places on the x-axis. These two values which we found on the graph for x are two real irrational numbers. This you will not be able to easily prove on a graph, but when we go on to solving a quadratic equation using the quadratic formula, you will be able to see what we mean by two irrational solutions. Let us now go to rule number 3. If the discriminant equals 0, this tells us that the quadratic equation has only one real solution. Let us look at an example. Given the quadratic function, y equals 9x squared plus 24x plus 16, a equals 9, b equals 24, and c equals 16. The discriminant is given by the formula d equals b squared minus 4 times a times c. Substituting these values gives us d equals 24 squared minus 4 times 9 times 16. This equals 576 minus 576. D equals 0. Therefore, this quadratic function has only one real, rational solution. Let us examine this on a graph to see what we mean by one real solution. This is how the function looks on a graph. One real solution means one value for x. This is the only x-intercept. This value is approximately negative 1.3. Let us now go to rule number 4. If the discriminant is less than 0, meaning d is a negative number, well, this tells us that the equation has no real solution. Let us look at an example. Given the quadratic function y equals 3x squared minus 4x plus 5, a equals 3, b equals -4, and c equals 5. The discriminant is given by the formula d equals b squared minus 4 times a times c. Substituting these values gives us d equals -4 squared minus 4 times 3 times 5. This equals 16 minus 60. D equals -44. Therefore, this quadratic function has no real solution. Let us examine this on the graph to see what we mean by no solution. This is how the function looks on a graph. No real solution means the graph does not touch the x-axis, so there is no x-intercept. So you can see that there is nowhere on this graph that the function touches the x-axis. We are now going to talk about the vertex and axis of symmetry. Looking at the vertex and axis of symmetry, the vertex of a quadratic function is the turning point on the parabola. Remember, the curve is called a parabola. So it is at this point where the graph changes from a decreasing to an increasing, or vice versa. The line of symmetry is a vertical line which divides the parabola into two equal halves. It intersects a parabola at its vertex. So this vertical line is the axis of symmetry. The formula for the equation for the line of symmetry of a quadratic function is this other portion of the quadratic formula, the minus b divided to a. The equation for the line of symmetry is given by this formula, x equals minus b divided by 2 times a. Let us look at an example. Given the quadratic function y equals x squared plus 5x plus 2, we want to find the equation for the line of symmetry. Having y equals x squared plus 5x plus 2, a equals 1, b equals 5, and c equals 2. The formula is x equals minus b divided by 2 times a. Substituting these values into the formula gives -5 divided by 2 times 1. Then we have -5 divided by 2. Therefore, the equation for the line of symmetry is x equals -2.5, and the x-coordinate for the vertex is -2.5. Let us look at this on the graph. Here it is. The x-coordinate for the vertex is at x equals -2.5. The line of symmetry is this vertical line which crosses on the x-axis at x equals -2.5. So we can see that the equation for the line of symmetry is represented by the vertical line crossing the x-axis and intersecting the curve at its vertex. Therefore, the equation for the line of symmetry is x equals -2.5. Okay guys, this is the end of this lesson. We will continue in another video, where we will go into using the quadratic formula to solve a quadratic equation. This lesson was presented by Peter Smith. Please join me in another lesson where we learn more important math topics. Let us think of education as a tool to develop our greatest abilities, because in each of us, there is a private hope and dream.